Hello, my dear students. Welcome to the world of chemistry. Today we are going to discuss about geometrical isomers. In the lecture, we cis and trans isomers detail. Previous year questions also will be discussing. So first, you should understand what is geometrical isomers. Actually, on the isomers, we structural and stereo isomers classify பண்ணிக்கலாம். And the stereo isomers ஒரு type தான் the geometrical isomers. It is having the same molecular formula, same structure, but these isomers will differ in the relative arrangement of atoms. Atomோட positioningல மட்டும் there will be having a difference. Other than that, this structure, all the molecular formula, everything remains the same. For example, we'll be seeing one compound here. The name of the compound is butene, but2ene exactly. Okay, see here the important condition. Okay, or compound on the geometrical isomerism show pannamna the important condition in the carbon illengla. In the carbon is we can able to see that this is sp2 hybridized. How? Number of sigma bond plus lone pair. Hybridization கண்டுபிடிக்கிறது உங்களுக்கு தெரியும் நினைக்கிறேன். Videos also we have done, description we can able to see the video. So here you are having 3 sigma bonds. 3 sigma bond na sp2 hybridization. கரெக்ட்டுங்களா? So இந்த sp2 hybridized carbon பக்கத்துல நீங்க ரெண்டு different compounds different groups attach பண்ணா மட்டும் தான் geometrical isomerism show பண்ணுவேன். So for example, if I am going to take a compound like this one, CH3H, and here both the sides you will be having CH3 groups, the same groups attached to central atom, then this one show the geometrical isomers. புரியுதுங்களா? என்ன சொல்றேன்? கார்பன் கார்பன் டபுள் பாண்ட் இருக்கும். ஓகே, sp2 ஹைபிரிடைஸ்டு கார்பன் இருக்கும். இந்த ஒரு கார்பன் கூட ஜாயின் பண்ணிருக்கிற ரெண்டு குரூப்புமே சேமா இருந்துச்சுன்னா it won't show geometrical isomerism. So இங்க பாத்துருங்க, இந்த கார்பன் கூட ஒன்னு மீத்தைல் குரூப், ஒன்னு ஹைட்ரஜன். இங்க ஒரு மீத்தைல் குரூப், இங்க ஹைட்ரஜன். Both are different. But here interesting thing is this CH3, both the CH3 of the carbons are in the same side of the double bond. இல்லையா? double bond ஓட same sideல தான் same identical groups இருக்கு. The isomers in which two identical atoms or groups lie on the same side of the double bond we'll call it as cis isomer. எப்படி? So double bond ஓட same sideல identical groups வந்துச்சுன்னா we'll call it as cis isomer. So இது double bond ஓட same side, இந்த சைடுல இங்க ரெண்டு ஹைட்ரஜன். ஓகே, opposite sideல இங்க ரெண்டு methyl group. So ரெண்டு identical groups தான் attach பண்ணிருக்கு. So we can call it as cis isomer. அப்படினா trans isomer எப்படி இருக்கும்? ஆமா, the two identical atoms should be there, but it should be there in the opposite side of the double bond. So cis வந்து same side of the double bond இருக்கணும். trans வரும்போது என்ன ஆகுது? methyl group, ஒரு methyl group இந்த பக்கமா இருந்துச்சுன்னா இன்னொரு methyl group opposite sideல தான் இருக்கணும். So இப்படி இருந்துச்சுன்னா we'll call it as trans. புரியுதுங்களா? simple as that. So transல ரெண்டு groups வந்து identical groups வந்து opposite sideல இருந்துச்சுன்னா trans. ரெண்டு identical groups வந்து same sideல இருந்துச்சுன்னா cis. This is what we are calling as cis-trans isomers. Okay, so if you look at the example, this is very important example that they have asked in many times in many question papers. So this is but2ene. இந்த ரெண்டு ஸ்ட்ரக்சர்ஸும் பாத்துருங்க. எத்தனை கார்பன்? You can count the number of carbons, 1 2 3 4. Okay, so this is gonna be but. Then there is a double bond, so but2ene. இங்கேயும் 1 2 3 4 4 carbons, there is a double bond, again but2ene. So idum but2ene da, idum but2ene da. So same molecular formula, same structure, but what is the difference? Look at this carefully. Here methyl group on the same side, here methyl group on opposite side. So when the methyl group is on the same side, we'll call it as cis isomer. When the methyl group is in opposite side, we'll call it as trans isomer. You can able to identify that very easily. This is trans isomer. So thus cis and trans isomers have same structure but have different configuration, different arrangement of atoms or groups in space. Spatial arrangement different இருக்கும். So in the cis and trans isomerism show பண்ணோம்னா கண்டிப்பா they should have a restricted rotation. இப்போ கார்பன் கார்பன் டபுள் பாண்டா இருக்குன்னா that is you will have restricted rotation around this bond இல்லைங்களா? So that is why they are showing this geometrical isomerism. Single bond will not be having that restricted rotation. They can rotate in any way. So அதனால தான் நம்ம conformers படிச்சோம் alkene இல்லைங்களா. Hope you will be knowing about that conformers. Fine. So this is what cis and trans butene. And because of this difference in the arrangement of atoms or groups in space, அவங்களோட melting point, boiling point எல்லாமே different ஆகும். So okay, structure எல்லாமே same தான், but வந்து அவங்களோட spatial arrangement different இருக்கறனால cisக்கும் transக்கும் melting pointலும் boiling pointலும் stability எல்லாம் difference இருக்கும். Let us see that. Look at the cis and trans butene. If we talk about the boiling point, cis buteneக்கு boiling point is 277 Kelvin. Trans buteneக்கு boiling point 274. Even though it is less, only a slight difference of the 3 Kelvin, but there's a difference. Yeah. So we can say that cis butene, and choose the incorrect statement எல்லாம் வரதுக்கு வாய்ப்பு இருக்கு இல்லையா. So just remember that cis butene is having higher boiling point than trans butene. Trans butene compare பண்ணும்போது cis butene boiling point higher இருக்கும். Just remember that one. And இன்னொரு interesting factor நீங்க சொல்லணும்னா, if you look at the trans, you can able to see that in the methyl group இல்லைங்களா, methyl group னா bulky group தான். When you compare with the hydrogen, they are bulky groups. So trans வந்து bulky groups are stay away from each other. ரெண்டு bulky groups நிறைய distance keep பண்ணிட்டு தான் இருக்கு. So என்ன பண்ணுவாங்க, அவங்களுக்கு in between இருக்க repulsion கம்மியாகும், steric hindrance கம்மியாகும். But when two methyl groups are on the same side, methyl group same side இருக்கும்போது அவங்களுக்கு in between இருக்கிற interaction அந்த repulsion வந்து அதிகமா இருக்கிறதானா, steric hindrance அதிகமா இருக்கிறதானா வாய்ப்புகள் நிறைய இருக்கும். So what we can say that if you go with the stability of the cis butene and the trans butene, you can say that trans is more stable. Trans is more stable. Why trans is more stable? Because this bulky groups are aligning in the opposite direction. They are far away from each other, so steric hindrance will be minimum. But in this is they are on the same side, so there will be steric hindrance. So trans is more stable, but boiling point of cis is more than the trans. Just remember that one. Then if we talk about the polarity, cis form of alkene is found to be polar in nature than trans. So which is more polar? Cis is more polar. If you talk about that in structure, again நம்ம butene எடுத்துக்கலாம். This is the NCERT diagram they have given about the butene. Look at that. Butene trans butene பாத்துருங்க. In the CH3C bond இல்லைங்களா, this CH3C bond, in the dipole moment is coming in this particular direction, in the dipole moment is coming in this particular direction. What is happening? This will automatically cancel each other. So in the dipole moment cancel ஆகறனால என்ன இருக்கும், mu வந்து dipole moment 0 இருக்கும். When the dipole moment is 0, we can say that it is non-polar. புரியுதுங்களா? So which is non-polar? Trans butene is non-polar. But when you go with the cis பார்க்கும்போது you can able to see that one is like this one, another is like this one. They are not cancelling entirely. அது opposite வரல, cancel ஆகாது. So additionally you will have some resultant dipole moment. So you can able to see that cis க்கு 0.33 d by dipole moment இருக்கும், and mu will be 0 for the trans. So trans is non-polar, cis is polar. That is why they have given cis form of alkene is found to be more polar than the trans form. Here நம்ம discuss பண்றது butene இருக்கனால trans butene dipole moment is 0, it is non-polar, and here cis butene is polar because it is having a resultant dipole moment. Just remember again another important thing. Then again one more thing you should be noting. It is observed that trans isomers has highest melting point than cis form. It's always confusing. Choose the incorrect statement வந்துச்சுனா கண்டிப்பா ரொம்ப கன்ஃபியூஷன் கொடுப்பாங்க. பாயிலிங் பாயிண்ட்க்கு எல்லாமே நம்ம வந்து butene அப்படி வச்சு சொல்லிக்கலாம், ஓகேங்களா. butene பாயிலிங் பாயிண்ட் என்னது, சிஸ்க்கு அதிகமாகுது. cis will have more boiling point than trans. When it comes to the melting point, அவங்க என்ன சொல்றாங்க, in solid state, in solid form, trans will have more melting point than cis. This is in the case of melting point. Stability நம்ம பார்த்த, trans will have more stability than cis isomers. Okay. And another important thing, very important thing. So who all can form this cis and trans isomers? இப்போ நம்ம பார்த்துட்டோம் இல்லையா, or model பார்த்துட்டோம். So we can say that these alkenes with these types also can form geometrical isomerism. That is, we have seen compounds in the form of CXY, CXY. இல்லையா? இந்த மாதிரி ஃபார்முலா நம்ம பார்த்துட்டோம். This is what we have seen in cis-butene. அவங்க என்ன சொல்றாங்கன்னா, இந்த மாதிரி மட்டும் இல்ல, the other forms is possible. C double bond C, X, Y here, and here X Z. That is also possible. So XY, XZ is also possible. Then another category அவங்க என்ன சொல்றாங்கன்னா, C double bond C, XY, and ZW. So நாலு குரூப்புமே டிஃப்ரெண்டா இருந்தாலும் அந்த ஐசோமரிசம் possible தான், இந்த geometrical isomerism possible தான் அப்படி சொல்றேன். So just remember, geometrical isomerism எந்தெந்த types of compounds form பண்ண முடியும்னா, these three types of compounds can able to form cis-trans isomerism. But remember, இந்த கார்பன் கூட ஜாயின் பண்றவங்க ரெண்டு பேருமே டிஃப்ரெண்டா இருக்கணும். எல்லாருமே டிஃப்ரெண்ட் தானே. ஸோ ரெண்டு பேருமே சேமா இருந்துச்சுன்னா there is no possibility of showing the geometrical isomerism. This is very very important. So this யாருக்கெல்லாம் geometrical isomerism form பண்ண முடியும், அந்த formulas you should remember. Okay, now we'll be moving to the previous year question. We'll be detailing checking one by one. Questions are going to be very easy if you know the concept. Look at that. This is 2009 question. Which of the following compounds will exhibit cis-trans or geometrical isomerism? Which of the following compounds will exhibit cis-trans or geometrical isomerism? Look at the option. Direct நம்மளுக்கு இருக்கு இல்லையா? 2-butene or butene. இப்போ நாம் பார்த்தோம் butene ஓடது NCERT ல இருக்கிற ஸ்ட்ரக்சர் தான், அதனால அந்த ஸ்ட்ரக்சர்ல இருந்தா கேள்வியும் கேட்க போறாங்க. Butene. Then if you go with the another question, which is maximum stable? 2000 question, which is maximum stable? 1-butene, cis-2-butene, trans-2-butene all have same stability. We have seen the stability also. Trans will be more stable than cis because yeah, they will have this bulky groups. You will have the bulky groups on the opposite side. Yeah, bulky groups on the opposite side இருக்கனால என்ன ஆகும், their repulsion will be minimum, their steric hindrance will be minimum, so they will be more stable because they are far away from each other. Now next question, look at that. Which of the following has zero dipole moment? 1996 question, somewhat very old question, but questions are relevant. Zero dipole moment. Zero dipole moment varnamnalum we have seen. Yes, நம்ம NCERT ல பார்த்தது. ஆமா, அந்த ஆப்ஷன் இருக்கு இதுக்குள்ள. Trans to butene, it is having dipole moment 0. But if it is cis, yeah, it is having dipole moment of the range of 0.33 d by. You got the answer. Easy. Now look at that. This is some interesting questions of JEE mains. We'll be checking that too. In the following structure, the double bonds are marked as 1, 2, 3, 4. Geometrical isomerism is not possible at which site? So in the 4 site கொடுத்திருக்குங்கல்ல, 4 double bond கொடுத்திருக்காங்க. 1 here, 2, 3 and 4. அங்க என்ன கேக்குறாங்கன்னா, இதுல ஏதோ ஒரு double bond வந்து geometrical isomerism not possible. இதுல எதுல தான் geometrical isomerism not possible இருக்கும், that is not possible அல்லாமலே இருக்கும். So if you look at this closely, you can able to see that நீங்க 1 2 3 4 போயிட்டேனா ஈஸியா கண்டுபிடிச்சிடலாம் இல்லையா? நம்ம எப்பவும் ஆர்டர் 1 2 3 தானே போறேன். Look at the look at the first structure is carbon, double bonded carbon. Double bonded carbon பக்கத்துல இது எந்த group? This is a methyl group. Again this is a methyl group. So double bonded carbon sp2 carbon ஓட ரெண்டு சைடுலுமே சேம் குரூப் அட்டாச் பண்ணிருக்காங்க. So sp2 hybridized carbon கூட ரெண்டும் சேம் குரூப் அட்டாச் பண்ணிட்டேனா they won't show geometrical isomerism. Initially we have discussed. So யாரு கொடுக்க மாட்டாங்க? First one will not show. மீதி எல்லாத்துலயுமே டிஃபரெண்ட் தானே. Yes, here methyl group, here one big group, here one hydrogen, here one hydrogen will be there, right? Here another big group, here one methyl group, here another group, here one methyl group, here another group. In this compound, here methyl group, here another group, here methyl group, here ethyl group. So all these are different, so they can show geometrical isomerism. But inga rendume same varudanaala we cannot able to show the this particular first cannot able to show geometrical isomerism. Okay, one more question. This is the last question. It's interesting question. In the question one, if you read it again, it's a JEE main question, you'll be get the answer. When 2-butane is treated with H2 Lindlas catalyst, compound X is produced. So you got some compound called X. Then what they are telling, when the same butane treated with sodium and liquid ammonia, it produces Y as a major product. So namakita 2-butane தான் இருக்கு. Lindlas catalyst கூட Lindlas catalyst யூஸ் பண்ணிட்டு நம்ம hydrogenation பண்றோம். Sodium in liquid ammonia hydrogenation பண்றோம். Look at this. We have discussed about this Lindlas catalyst and Birch reduction. This sodium in liquid ammonia, the reaction is Birch reduction. Birch reduction. So in the Birch reduction pathiyum, then in the Lindlas catalyst pathiyum, we have done a video. The link will be given in the description. You can check that. Okay. So what is happening? Simply solitana, when 2-butane partial hydrogenation of alkyne da nadakudhu to get alkene. So 2-butane when treated with Lindlas catalyst, you will be getting cis-butene. Cis product. Okay, what you are going to get? You will be getting cis-butene. இதுல உங்களுக்கு Lindlas catalyst யூஸ் பண்ணிட்டேன். First one Lindlas catalyst யூஸ் பண்ணிட்டேன். Second வந்து நீங்க யாரை யூஸ் பண்றீங்க? Sodium in liquid ammonia. Sodium in liquid ammonia na that is Birch reduction. This is Birch reduction. Sodium in liquid ammonia use panni partial hydrogenation பண்ணும்போது we will be getting trans product. So what you are going to get? Trans-butene. So இதுதான் உங்களோட X, இதுதான் உங்களோட Y. So you got your X and Y. X ஐயும் Y ஐயும் தெரிஞ்சிச்சுன்னா மீத என்னதான் தெரியணும்? You got X as cis, Y as trans. Now we'll read. Y has higher dipole moment and higher boiling point than X. So dipole moment and boiling point பத்தி தான் சொல்றாங்க. Already எல்லாத்த பத்தியும் தெளிவா NCERT ல மென்ஷன் பண்ணிருக்கு. cis butene பத்தியும் trans butene பத்தியும் NCERT மென்ஷன் பண்ணிருக்காங்க இல்லைங்களா? So who is having more boiling point? Cis will have more boiling point. Who is having more dipole moment? Again cis will have more dipole moment. இதெல்லாம் நம்ம பார்த்ததுதான். Nothing is new. So cis will have more dipole moment, cis will have more boiling point. So the answer will be cis na yarunga, cis na X. So X will have higher dipole moment, X will have higher boiling point. Read it. So you can apply that. Do n number of questions, then everything will be sorted out. So that's it for this session. So we'll be coming with another video soon. Stay blessed, study hard, success will find you soon. Thank you.